All right, this is number 4 on the multiple choice, so y'all take a look at that for just a minute.
I thought we went over. Hold on, let me we had this question. It was on the video. I remember. Did I remember?
It's not a bottle.
Oh, what is this one? Can you watch the video first? Dude, I can do normal. You look kind of make that. Did you watch this one? No, well, right, the introduction. Like all the things, actually, look at that, dude, yeah. Yeah. You come with school shoot. Oh, yeah, we didn't. Okay. Oh, you did that scrambled.
Did you come up with your question?
What?
Yeah.
What?
Okay.
Want to say that again?
Chemistry related?
Yeah.
Oh,
We already did it, so
no,
we really don't have to.
Oh, I forgot the camera.
Overrate lots of class.
we did.
It was just about the video though. Yeah.
All right, let's look at this one. Remember this 4? All right. A kinetics experiment is set up to collect a gas that is generated from a sample of chalk consisting primarily of calcium carbonate. It's added to a solution of ethanoic acid, also known as vinegar, by the way. Okay. The rate of reaction between calcium carbonate and vinegar is determined by measuring the volume of gas generated at 25 C in 1 atmosphere, also known as standard conditions. As a function of time, which of the following experimental conditions is most likely to increase the rate of gas production? So what would make this reaction happen faster? Okay. Well, let's see. We made a list the other day, right? One had to do with increasing the concentration of the reactants. One had to do with increasing the temperature. One had to do with increasing the surface area, and the other was add a catalyst, right? So 4 things we could do. Some textbooks, if you look this up, will include a 5th. I may have said this up there, I don't know. But the 5th would be the nature of the reactants. I don't include that on the list because there's nothing we can do about that. Okay, like for example, sodium reacts better than lithium, but that's not, to me, that's not really, I just don't include that because I always try to think of it as what are 4 things that you can manipulate somehow as a chemist. Like I can't do anything about the fact that lithium reacts slower than sodium, just like that. Okay. All right, so we go down through this list. Decreasing the volume, that wasn't, the volume of reactant was not on the list. Concentration was on the list, right? Nothing about volume, that's not it. Decreasing the concentration, no, what would that do?
Slow it down.
It would slow it down, not speed it up. Decreasing the temperature, what would that do?
Slow it down.
Slow it down, not speed it up. Decreasing the particle size by grinding it into a fine powder, that is increasing the surface area of that reactant. Okay. So D. By the way, what gas is being produced in this little reaction? I might measure the volume of gas generated. What gas is it?
Probably poisonous.
Nope.
No. Said it was ethanoic acid. Said it was calcium carbonate, ethanoic acid.
Oxygen is not a terrible gas, but it's not right.
Oh, it's not a terrible gas. Okay.
Methane's not a great gas. It's not totally unreasonable though. We have carbon and hydrogen. All right, take 30 seconds and write a balanced equation for what's going to happen right there. Just while we're at it, we'll just do that.
This water right here, it tastes good. And your class?
No? Jacksonville City tap water. That's nice.
No, when I moved here my first year, the water was blue. Up there.
I can't read that from over here.
Y'all pull it up on your screen there. Do what?
Oh, I'll look it up.
What kind of reaction is this going to be? Any gases up there? Remember the trick to this? Almost certainly did. What's that right there? Carbonic acid.
Is it, when you can like remove the.
Right now. Okay. Carbonic acid, all right, carbonic acid spontaneously decomposes. Okay. Carbon dioxide and water, all right? So anytime you have a chemical reaction that produces carbonic acid, it's going to automatically go to CO2 and water. So the gas that they're measuring the production of here is CO2. So you're going to get that from you get CO2 from the decomposition of carbonate, right? You should know that. Metal carbonate is decomposed to make CO2, metal oxide to CO2, right? It's a statement you're supposed to know. And then if you react a carbonate compound with an acid, it's going to make carbonic acid, which is going to decompose into CO2 and water. So either way, you're going to get CO2. Lots of bubbles. All right, good. Next, number 5. Same situation, different question. Well, different answer choices, I should say. Maybe it's the same question.
Yeah.
It's the exact same question? Okay, I thought it was the same situation, but a different question.
No, same.
It's 22 degrees it's 22 degrees instead of 25 degrees.
Is it?
Yep, how about that? That's weird, okay. All right, number 6. Number 6.
So that wouldn't change anything?
Hmm?
The temperature wouldn't change anything?
That's like many.
That's weird.
All right, take a look at that. Do y'all remember Beer's law?
Yes.
Okay. So absorbance and concentration are directly proportional, right? Okay. So you can use the same numerical patterns with absorbance as you would use with concentration. You're just trying to find the orders of something, or just looking for some kind of pattern like linear or hint here, half-lives or whatever, then you don't have to convert absorbance to concentration because they're directly proportional. So there'll be different numbers, but the same mathematical pattern will be there. How many half-lives does it take to get? You only have 75. Where you've used up 75% of something.
Two.
Yes, 2 half-lives, right? Okay. Well, we start with 0.62. What's half of that?
0.31.
0.31. How long did it take to get to that point? 150 seconds, right? Cut that in half, what would it be?
75 seconds.
Don't cut them out.
I'm sorry.
You point at the numbers I'm talking about here. Okay, so to get to 75, to use up 75%, remember the chart we did on the board, right? Okay, so how many half-lives does this undergo? Well, first off, let's back up and point out it said it was first order, right? Somewhere in there, did I say that? It needed to. There we go, first order with respect to whatever that is, okay? So first order kinetics say that the half-lives are all the same, right? Okay, so if the first half-life, if it takes 10 seconds to get rid of the first half, it will take 10 seconds to get the next, cut that in half again, and so on and so forth, okay? So first order kinetics, all half-lives are the same. All right, and if you want to get 75% of it gone, that's 2 half-lives, right? We not do that on the board the other day? Right, the whole chart we filled out? Huh? And everybody went home and studied it, right? So let's talk about it though. So if I cut something in, how many people are in here right now? Let's say there's 12 of you, there should be 12. Let's say Kalani, let's pretend Kalani. So there's 12 of us, count me, so there's 12, okay? So if we cut that in half, down to 6, right? If you cut that in half, how many, what are you down to? 3. What percentage of the classes left the room at that point?
25%.
Left the room? 75% have left the room. Okay.
I had to go back and look at it.
And y'all wonder why they're having a math pull-out group for the ACT.
Oh, that's right.
Okay, so it's like.
I wasn't here that day. I'm not even in it.
I know, look, it's a real thing. Honestly, not, I ain't talking about nobody. But our school-wide math scores are as bad as they can be.
Really?
It's below the state average.
Our school?
So we're like Mississippi.
Our school math scores are below the Alabama state average.
We're a little bit better.
What is ours, the seniors, do you know?
I don't know, but it's below the state average in math.
Carol?
What does that say?
Huh?
What does that say?
It explains why y'all don't understand what I'm talking about.
Yeah, I thought ours has to be worse.
No,
I mean, I'm just telling the truth. Y'all don't have any,
I thought our junior class was average is way worse.
it is what it is. It's probably,
Yeah,
I think,
it's a
it's-
waste of
the
time.
problem is
Yeah.
it's dropping, like it's not getting better.
Let's go, okay, this is where I'm getting
Because
confused.
Drastic measures
I
are necessary.
this is where I'm getting confused. So like, whenever I'm thinking about it, like, if I have something, like, if I multiply something by 2, 20, well, by,
We're not
yeah,
multiplying by 2.
Well,
But go ahead, I want to hear where this goes.
25, 50, 75, right? So I'm thinking wouldn't
That's
that take 3 half lives? Like, that's why I'm getting confused, how we
No,
doing
you're
this
adding.
one 2?
You just
So,
added, you didn't
You're
multiply.
starting with 100. So you're
So
starting with 100.
You start with
have it,
100%.
you
We have
have it,
100%
you have
population
50,
right
you
now,
have-
12 people,
you have-
right?
That's 50.
It's
So it's 50,
decreasing
60,
as
and
the,
then you have 50, and that's 25, that's 25, 75.
Reactants are consumed and products are produced in a chemical reaction, correct?
okay, I got it now, I got it now, I got
What
it.
was I doing in regular chemistry the other day that was like
How?
such simple math and they were just like, oh, this morning, we were balancing the equation and we need to use a fraction. And somebody correctly said, all right, so we had 2 oxygens, we needed 15. And somebody correctly said, well, we should multiply by 7.5. I said, good, good. I said, what is that as a fraction? Crickets. Crickets. People pulled out their calculator.
I don't even know.
I don't know.
Y'all don't know either.
Wait a minute.
Like,
So
you don't have
seven,
4,
seven,
no, 3,
What's,
it's 3.
what's 7.5 written as a fraction?
15
So it's 3,
15 over 2.
Oh, okay. It's
Right. But see, the fact that y'all can't just say that. And look, that's nobody in this building. That's across the street, right? Like the fact that you got out of elementary school and when somebody says what 7.5 is a fraction, you just don't go, 15 over 2. Like the fact you can't just say that means you missed.
Everybody.
Y'all
Yeah,
missed.
we're writing it.
Because here's the underlying problem. And because I want to make sure I clarify something when I talk about our math scores here. I'm not talking about our math teachers at the high school, okay? That may or may not be part of it, I don't know. But from my experience of teaching students here over the last several years, there is a lack of fundamental number sense. And that's elementary stuff. Like knowing that 15 over 2 and 7.5 are the same thing is not, that's 4th grade, 5th grade, 6th grade. That's not here. So your high school teacher, like how in the heck do you teach geometry to somebody that doesn't know fractions, right? How do you teach algebra to somebody that can't do 15 over 2 and 7.5 in their head in 2 seconds or less, right? So
We had to count. It took us a minute.
y'all see, that's the problem. So it's not, just to make sure we understand that I'm not talking bad about Edwards or Mize or Vanguard, whoever y'all have had or have now or have had. It's system wide. It's all the way down to kindergarten. Like somebody, somehow, some way in this school, and I don't know the answer to it, but somehow in this school system, we are not teaching math because kids y'all don't have what's called just basic number sense. Like this conversation of 100% down to 50, cut that in half again, that's 20. Like I can just tell by the look in y'all's eyes, y'all never thought about math problems like that. And that's not a high school math problem. That's an elementary math problem. And see, y'all know what we're doing. And that's somebody in 4th, 5th, 6th grade fault. Like, I don't know who, and I don't know where, but anyway, but it's a problem that I guess we have to acknowledge exists before we can fix it. All right, so now, back to our example. There's 12 people in the room. If it takes 10 minutes to clear out half the room, 10 minutes later, there'll be how many people in the room? 6. 10 minutes after that, there'll be how many people, including that it's assuming that our room clearing is undergoing first order kinetics, okay? Then our 10 minutes after that, which would be a total of 20 minutes, how many people are still in the room? 3, okay? And then we run in, okay, hang on one second. Then we run into a really strange problem that we run into here, is it after 30 minutes, how many people would be in the room? 1.5. I don't know how we do that. But anyway, that's where you get into some other things, all right? Okay. That's where the model breaks down a little bit. But point being, in first order kinetics, if you look here, we started at 0.62, right? How long did it take for that to get cut in half? 150 seconds, okay? So how long should it take for it to cut in half again? Another 150 seconds, which would be how much? 300. Is 0.15 half of 0.31? Pretty close, right? Rough numbers, yes. Some rounding or something. It's science, right? It's not exact. Sevgi, what was your question?
Okay, so if it takes a certain amount of time to get 6 people out of the room,
Uh-huh.
because it's half, how come in that same amount of time, another 6 people hasn't left?
All right, because if you were chemical reactants bouncing around in a room, right, then the fewer you are, the slower everything happens.
Okay, that
Right.
makes sense.
And if you're trying to go out that door, let's just say you're diffusing out the door. It's a gas, right? The fewer of you there are, the less probability that one of you in your constant random motion, kinetic molecular theory, right? So you're constant randomly bouncing all over this room. The fewer of you there are, the less chance one of you actually bounces out the door. So there you go. So to answer the question, the answer here is C. Right? I don't know what answer towards D is, but there sits the right answer. All right. Did y'all memorize multiplication tables in elementary school?
Yeah,
Y'all
we
did
did
that,
time
right?
test all the
Y'all did
time.
that. Okay. Y'all do division?
Yeah,
No,
kids
in
aren't
multiplication,
really-
I
You
did.
do time division?
Multiplication was only to the
I'm surprised it's still.
Only to the 12s. That's fine. That's probably enough. But you didn't do division.
No.
Not as much as we should.
I did.
See, that's the thing, because what's a fraction?
No.
It's a division problem, right?
We really didn't learn long division. We did.
I mean,
See, there's,
I
to me,
remember
there's a
learning long
skill
division.
there. It's not some, look, it's not the ability to do the process of long division, right? Because we all have a calculator, right? It's the number sense that you get when you sit there and work through that puzzle. Like long division is like a puzzle, right? I have to divide here and put this number up there, and then I multiply and put this number down here, and then I do what? I subtract, right? And then I move this number down here, and then I divide, and then I multiply, and then I subtract, and I move this number, and you do a couple, 500, 600 of those, and some 9 weeks of the 3rd grade, right? And you get a sense of numbers, like just what divided by what's what, and how to approximate, and you get a rough idea that how many times does 5 go into 17? 3 and a little more, right? You get the students, not y'all, last year, year before, the last several years, can't do like don't have any sense of the concept that 75 divided by 10 is 7.5.
Some people think like the harder stuff is easier because they actually know and they were taught correctly how to do it.
Some of it.
So, like, you know how some people are like the harder stuff's easier and the easiest stuff is like.
But when you start doing like mathematical logic like this and just reasoning, and you struggle with that because you don't have that little fundamental number sense, like just numbers, basic arithmetic. Like y'all missed basic arithmetic. Like y'all can do some algebra, and some of y'all can do calculus. But somewhere back in the day, y'all missed arithmetic. And math is taught in order. First you learn arithmetic, then you learn algebra, then you learn calculus. It goes in that order. And if you skip a foundational thing, because that's all this is just basic arithmetic. Y'all are the first people to be confused.
They're not giving kids the they would have that sheet of paper where it would just be filled up with multiplication problems, and you see how many of those exist.
Yeah.
They're not giving that. They get Chromebooks when they're 5 years old.
Yeah, exactly. It's a problem.
I'm right now, and I look at her math work, and I'm like,
And they have all this other weird way of doing it.
Oh my gosh, I was looking at like I would really do
Right. Somewhere in that's not teaching people how to do this. I don't know. All right, here we go. Let's go to the next.
I mean, I understand it, but it's
For like 4 minutes.
I won't.
I was like, oh, I just knock somebody out.
Like, how do you?
Number 7. Which of the following would make this happen faster?
Oh, I like these ones.
Make this happen faster is the same thing as increasing the rate of reaction, right? That's what we mean by that.
I already got it.
How you gonna make it happen faster?
I got it.
Got it?
I got it.
Yeah.
Would decreasing the temperature do it?
Oh.
No. Would adding a heterogeneous catalyst do it?
Yeah.
Yes.
Probably so, yep. Would increasing the volume have anything to do with it?
No.
No. And would removing hydrogen do it?
No.
No.
It's decreasing concentration.
That would decrease or cause it the equilibrium to shift to the left. That's a whole different unit. All right, let's talk about this word right here. Okay. Heterogeneous catalyst versus homogeneous or homogeneous, how do you pronounce it? Catalyst, okay? A homogeneous catalyst, okay, would mean it's the same phase. So if you use some kind of a gas as a catalyst here, that would be homogeneous. The fact that it says heterogeneous catalyst means that whatever the catalyst is, it's not a gas. It's most likely going to be a solid. Okay. So just note that. I don't know if that will help you answer a question or not, but you need to know what it means. Something. It probably could show up and mean something, but that's what it means. So whether the catalyst is of the same phase as the reactants or not. Homogeneous, same phase. Heterogeneous, different phase. All right. Let's talk a little bit about catalysts for a second. Heterogeneous catalyst here would most likely be a metal, okay? Probably be some type of metallic substance, platinum or something like that. And one of these gases, probably the ethane, is going to stick to it. They're all flying around the room, right? They're flying around their container. And if one side of the container is a piece of metal, okay, that for whatever reason, ethane will stick to it, and ethane's going to stick to it and hold it still, right? So now the hydrogens are flying around the room, and they got a much better chance of running into an ethane if the ethanes are not moving also.
So catalysts are not part of the reaction.
They're not part of the reaction. No. They don't get used up during the reaction. So when the reaction's done, and all of that becomes ethane, so ethene all becomes ethane, the catalyst is still there, the same quantity as it was before.
It's just holding it, so
It's holding it still, basically, I mean, basically holding it still. If you're doing a biological catalysis thing, then you've got some big globular protein, okay, which there are thousands and thousands of them. Like the simplest one-celled organism has like 2,000 different somatic proteins. So, which basically run around the cell, grabbing molecules and holding them down. And then once it's reacted, it turns it loose and goes and grabs another. It just keeps running around the cell. And if it gets tired, it gets broken, then the DNA of the cell has a code for making another one. So it makes another one. To the tune of a very high-tech code, thousands of different enzymes. And the simplest living organism, which, side note, macroevolutionary theory has zero explanation for how that ever came to be, because it's statistically impossible. Something had to be. But that's another concept for another day. Number 8. Look at that. Did I say platinum? Gosh, I think I knew something. All right. If you see something written above the arrow right there, that's the catalyst, okay? All right, so if you see a substance, a name or a formula or whatever written above the catalyst, written above the arrow, that's the catalyst. If you ever see, just while we're talking about things written above the arrow, if you ever see a triangle, the delta sign written above the arrow, that means it was heated. I have no idea why that means heated, but it does, okay? That means it was heated. You see the little triangle, it's Greek letter delta. But if you see that written above the arrow, that means the substances were heated. You see the name of a compound or an element, then it's being used as a catalyst. All right, so same thing as before, but now it's being In the presence of a platinum catalyst as represented above, factors that affect the rate of reaction include which of the following? So which one of those now would make it happen faster?
If it can't fit, yeah.
What is
The choice of the catalyst.
Answer D is 1, 2, and 3.
What's C then?
Little less C.
Oh, no.
They owe you.
Oh,
No, 2 and 3, sorry. What are the choices here? Changes in the partial pressure. That a little bit. They don't tell you what's changing the pressure, but normally it would be the volume, so that's a no. Okay. If the partial pressure of hydrogen changed because you injected more hydrogen in there, that would increase the concentration, but they didn't say that, so I guess that's assuming that that's not what's happening. So that's not one of the choices. Particle size of the catalyst will help, right? The more, if you crush that piece of platinum up in little pieces, then you're going to have more little platinum atoms floating around in there that can grab hold of stuff. And of course, we know that temperature, right? But that's odd that they don't. Oh, it just says effect, doesn't say speed up or slow down, does it? Never mind. All right. So 2 and 3, answer D. No, it's not. Wait a minute.
There's an E.
There's
You
an
copied,
E.
you copied.
Oh.
That's it, but I don't.
What's the answer?
Is it E?
Is it E or D?
It's actually E. It's all
Yeah.
3, but that. Hang on a minute.
But how?
Let me read the whole question again. Make sure I'm not missing something. Factors that could affect. Okay. All right. That's. Okay. So changes in partial pressure could affect the rate depending on what you do to cause the partial pressure of hydrogen to change.
Okay.
Okay. Depends on what's the reason for that changing. Okay. So yes, that's possibly could change the rate of the reaction.
You said it depends on what you do to
Yeah.
the hydrogen.
If the changing of partial pressure changes the concentration of the hydrogen, then yes. If you do something else, somehow it doesn't change, which I guess it'd be hard to do one without the other. But either way, you got to read the question. Could affect, right? That means it's kind of an open. If there's any chance at all that it's correct, then it's correct. Oh wow!
What?
Really?
Yeah,
Pretty quick. All right. You have to remember tomorrow we're on number 8 or be on number 9. Hey, make sure we are
Video.
doing the videos, doing AP Classroom, doing whatever, going through multiplication tables,
Right.
take a fraction conversion quiz.
Carol is no longer going to be
Tired, get tired.
Yeah, he just switched positions.
Oh,
To be like an advisor or something.
What? Yes, I might.
I just-
I don't have a note. I
Mr.
don't
Carroll,
even.
Carlisle, go to the next vote. Say how-
I got
It's looking like he's gonna go to
Which number?
Chargers, and it's looking like Kirby. It's looking like Kirby Smart is going to move up and be the new coach of the Falcons.
The
Bears
bye weekend.
He's meeting with the Falcons, and he said that he doesn't like where college football is with NIL, and
I just fixed that. I just fixed to say, I can't see him doing that. Then he hit me. Wait a minute.
because he said it's just because he said at this point NCAA might as well as the NFL. He could get paid more to do it in the NFL.
One of the differences, the reason Saban, this is why I think Saban retired before he's away from it. The reason Saban did not do well, I think, in the NFL, not have to do well, could not control the roster.
Yeah.
Right? The GM picks the players, and the coach coaches to the GM. You're to show up practice today. College, Saban coaches players.
I was one of the least so bad. Not just suspension. I just want to. I really.
College used to be so much Nobody would ever see Alabama. They weren't ever going to
She's got work.
I
She's
don't
probably
know.
never go to any exhibition.
You might as well, that's right, you might as well be in the NFL.
You'd be crying.
Yeah.
Oh, I need to bring other
Actually,
socks.
It's
and
easier to
these
match
ones.
NFL roster in the NFL because they have contracts. And they're not all free agents.
So you at least
You just
know
tuck
how
them.
long.
Yeah, college, everybody on your team is on a 1-year free agency deal. It's chaos.
It's leg day anyway.
Yeah, I can see that. See ya.
Look at my socks.
Just tuck in the ruffles.
Well, what up, bud?
No.
Is that
It's actually Zay Leonard.
Zay who?
Leonard. You didn't hear this one right earlier? Zay
He
Leonard.
said Zachariah. How you gonna get Zachariah but can't get money right?
Oh, exactly. How do you not read Leonard?
In the third quarter, there were no passes.
Zay.
They only ran.
Bro, if I ask you like pay attention to this, what's something about the positive movement from 66? It's like the Mac booster. Because my Mac is like a 14, 15. If I actually pay attention, bro, you're gonna be getting that money. See you. I'm gonna lock in. Ain't that right? Ain't that right?
Ah!
What?
So it's-